All right, this is video 6. We're going to draw a vertical line. Um, we just completed a horizontal line, and we still have that code in front of us. I don't like to waste good working code, so we're going to kind of use this as our base. And just like this one, let's see. Let's change things just for the sake of change. We're going to move it to 20 rows from the top, and this time just 100 columns in from the left side, and we'll do 200 pixels, and this time we're going to call it tall because it is a vertical line. And because we need something a little bit more interesting, here, I still got our image up. Let's try, what's a good color here? Light blue. Keep it simple here. So it's going to be light blue 16. And again, these are kind of grouped by their color type. So there's our light blue 16. We'll grab that. Once again, all this just to be a little different. So our screen is still 320 pixels wide, and that does matter in our with our vertical line. So here we decided that we're going to do 20 rows and only 100 pixels from the left. So I've got a cool, oops. No, that won't work. Okay. So we're just going to come back here. Once again, we're going to do this math and make sure that we don't have any problems. 320 times 20, 6,400 plus 100 and times 2. All right, so we can see it's still 4 hex values. We're still well within range, so we are going to leave that math there. Okay, and all right, so we're 200 pixels tall, so we actually need to go to oh, yes, this is going to be very different. Once again, our original strategy with the horizontal line was to calculate our ending address, but we're not filling in all of the spaces. We're only going straight down in a row. Oh, I'm going to actually throw in here, because we are still doing a 32-bit value for our color. Actually, you know what? We'll just comment that out, and that will give us, okay. From our horizontal line, we were actually filling in 2 pixels at a time. And so that is changing because we want a single pixel tall line. And so we only need to do this one instruction and load the pixel value once. If we had both of these, it would simply be 2 pixels wide as we work our way down. Okay, so here's our starting address. So this time, instead Instead of calculating our ending address, we need to, we can, let's use a counter. Once again, we're going to do this a little different just because we can here. So T2 will be our counter, and so we're going to do an initial value of we're going to 0 plus 320, which is the number of pixels wide that our screen is, and so that will, in the frame buffer, it will allow us to move down one line by adding 320. That's not quite right. No, that isn't what we want. I'm sorry. We want 200 pixels tall. So T2 is our counter. A little bit more like a for loop where we're initializing our I or index value. And so it's just a counter. We're just going to work through it. And yeah. Okay. So we initialize the counter there. We are going to store our color, which again is just the upper two, or the LUI light blue value, into our frame buffer at that point. So the store is still perfect, still totally works, and what we need to do is we need to add I T2 from T2, and we're just going to add 1. Actually, no, we're going to add a -1. And so we will subtract as we go through, and so we're subtracting from our counter, and we're going to do add I to T1 from T1, and we're going to add our 320, which is our line. Now, we're going to do that. Once again, until you know what you want to put into that line, into the delay slot, stick with a knob. If you start there, you can't go wrong. And once we know that this code works, we can look and we can see we should be able to move one of those two lines into the knob, into the delay slot, and replace the knob. But until we know for sure that our code works, we're not going to do that. All right, so we've made some good changes, and it compiles, usually a good sign. And I noticed a problem. I made the mistake, and we are still in the video 5 folder. So video 6. That was why it was pretty much guaranteed to compile. Move it over a little there. And now we will debug video N64. All right. F9 to breakpoint that. Let the code run. Uh-oh. It ran. And this is what it looks like when you crash MAME. So I probably got it stuck in a loop, and it's doing something bad. So what we'll need to do is go ahead and close MAME. And we're going to do the same thing. Once again, this series was about making mistakes and showing how we fix them. So we're going to rerun this. And get to our code and scroll down. So this is our loop, but this is where our line drawing routine starts. So that's what we want there, and I will go ahead and set this breakpoint just because. All right, and I just hit F5 and we run to the top of our drawing routine. So we're just going to step, which is F10, and kind of watch what happens. So we do have our first pixel out on the screen, and that looks pretty much like the way we want it. So then we keep going, and all right, so T1 and T2 are over here. They are clearly not the same. Okay, so real quick, what I see here is that T1 and T2, we're testing to see if they are equal or not. And over here on the left, we can see that they are not even anywhere near the same memory range or the same values at all. So we would expect them to be within a couple of thousand of each other or something like that if we were, if our values were correct. Here we're off by, well, let's go ahead and say over 2 billion. So we go back to our code, and what we should be doing here, we have our T2 value, and we initialized it to 200, and then we're subtracting 1 every time we go through our loop, and we're using it to compare here, but what we need is actually T2 compared to R0, because what we're doing is we're taking it from 200, subtracting 1 at a time, to make our 200 pixel tall line. So when it's done, T2 should be equal to 0. And so once again, this is how we're using that 0 register. It comes up all the time. Really, really useful to have a 0. So we're going to close this, go back to our command line, recompile, and run this. Okay. All right, so let's watch it draw. Oh, that was interesting. We can now see that we have 2 pixels, but they're just down the line from each other. So that's a logic bug. See, a couple of folks are watching. Any guesses as to what's happening here? Why it's not working as expected? So we're now drawing 2 lines at the same time. All right, so I will go ahead and explain what went wrong. Down here, we're adding 320 to T1 so that we can move down to the next line. But what we're seeing is it's not going to the next line. And the reason for that is our screen is 320 pixels wide, but we forgot that it's 2 bytes per pixel. So what we need here is we can do a ×2. We could technically write 640, but I like the ×2. And so to prove this theory, we say that the line should be 200 pixels tall, but we are drawing 2 lines. So if my theory is correct, our line should only be 100 pixels tall. So let's go ahead and just let this run. And yep, the screen is 240 lines tall, and that looks like just shy of half. So I'm going to say that it is a 100 pixel tall line. All right, so we're going to close MAME. We've already made our code change and saved it. So we come over here, we hit make and debug. And our breakpoint, let it run. And there is our single line, 200 pixels tall on a 240 pixel screen. And that looks great. And that is our vertical line. So again, just kind of doing some math, some numbers. Oh, and now that we have code that works, we can do our populate our delay slot. And so, oops, save that, compile, run. Right. And same line with one instruction faster in a loop. So it really can be an optimization savings there. All right. We're going to call this video a wrap. Thank you for watching.